Last example. All right, so here, this one's a definite integral, so we're not going to have a plus c on here. All right, looking at here, I've got the integral from 0 to 1 over the square root of 2. And if you want to, you can go ahead and change this to the square root of 2 over 2. If you want to leave it as 1 over square root of 2 for now, that's fine. But remember that we would usually write that as the square root of 2 over 2. Sometimes they'll do that just to kind of throw you off. All right, so looking at this and trying to think about our integration rules. First off, if you think back to what I said at the very beginning, when we're looking at these rules are not for integrating. These integrations that we're practicing now are not for integrating inverse trig functions. They're for integrations that will end up with an answer involving inverse trig functions. So notice how on this problem I've got an arc cosine in there. I don't have any integration rules. If you're looking at your chart, you don't have any integration rules that involve taking the integral of an arc cosine. Okay, we saw this same kind of thing back when we were doing natural logs, where sometimes if there's an integral of a natural log in there, we don't have a rule that we take for taking the integral of a natural log. We just have rules for what kind of integrals give you a natural log as an answer. So what we said back then and what we're going to say in this problem, same thing, is since I don't have a rule for integrating arc cosine, instead what I want to do is I want to try and rewrite this so that there isn't an arc cosine. Meaning I want to make my u arc cosine of x. Then my du, so I'm going to have to take the derivative of arc cosine, so we're going to have to go back up to our derivative rules, number 20, and it's going to be negative u prime. In this case, it's just an x on the inside, so negative 1 over the square root of 1 minus x squared dx. And this matches pretty nicely, except for the negative there, but negatives are easy to fix. Boom, boom. So now I've got a negative on the outside, integrating. The arc cosine has become a u. And then I basically have, so this is like a 1 here. This whole thing is becoming my du, so it's just u du. Okay, and that's going to be easy to integrate. I do have to put my things here, but remember, because I changed it, I'm going to have to change those as well. So my u, I'd figure out what the arc cosine of 0 is. So that's asking me the sine or the cosine of what angle gives me 0, and that's pi over 2. And then the other one, the u is going to be arc cosine of square root of 2 over 2. Again, you could put it as 1 over square root of 2, but if we're looking at our unit circle, this is how it's going to be written on our unit circle, and that's pi over 4. So this is going to become pi over 2. This is going to become pi over 4. So now I need to do my integration. The integral of u is 1/2 u squared, and I'm going to have to evaluate it between negative 1/2, or between pi over 2 and pi over 4. So that's going to be negative 1/2 of, so I just took this 1/2, stuck it out there, and I'm going to take pi over 4 squared minus pi over 2 squared, which is going to give me pi squared over 16 minus pi squared over 2 squared is 4. Now to subtract those, I'm going to need common denominators, so I'm going to make that a 4, change that to a 16. So now I have pi squared minus 4 pi squared, which is going to give me negative 3 pi squared over 16. And lastly, multiply those together. That gives me 3 pi squared over 32. All right, that is all for section 9.